look again at the histogram of men's neck sizes in exercise 18. Is the mean closer to 14, 15, or 16 inches, and why? Okay. So what does the mean do? In a histogram, what does the mean do to the data? What did I refer to it as in our notes? What? I didn't refer to it as half. It's the balancing point. So where should I move my finger to balance? Okay, do you think 15 would be a better place to balance it? Or 16? 16 definitely is a bad idea, and 14 is a bad idea. So I would say 20A would be 15. Okay, this is balancing point. The mean is the balancing point. If I were to put my finger under here and I had to balance this whole set of data on my finger, it had to stay horizontal. Where would my finger go? If it were at 16, which way would it fall? Wouldn't it fall down that direction? If it were a 14, it would fall down that direction. But if it were at 15, there's a chance that it would be balanced. That's a balancing point. That's what a mean is. Okay, a median is not the same thing. A median is the number in the middle. Okay, the number that's in the middle if you arrange them. That's a totally different thing. It's not even a calculation. That's the median is not even a calculation. All right, so why? Because it appears to be the balancing point. I mean, we just gave a reason why. Because on 16 and 14, the data would, if I were trying to balance it, it would tip one direction or the other, whereas I have a chance of balancing the data on 15. That's a perfectly good explanation. All right, is the standard deviation closer to 1 inch, 3 inches, or 5 inches? Okay, now interpreting the standard deviation is a challenge.
Excuse the interruption.
We have covered in our notes some things about standard deviation. Have you read your book? If you're trying to do your homework and you haven't read your book or reread your notes, no wonder you're lost. Okay? Part of learning this class is reading your book. I'm not going to read it to you. We're not going to read it together and take turns reading it out loud, but if you don't read it, you're missing half the material. Half the material. All right? So, standard deviation, we actually talked about a little bit in our notes. I don't know if I can find it exactly, but standard deviation is the measure of the distance, the distance that a lot of the data is from the mean. So if we know that in this data, the mean is 15, all right? So we've got this set of data and we know the mean is 15. We would expect most of the data to be within 1 standard deviation, plus 1 standard deviation above, and minus 1 standard deviation below. In fact, we did an example in our notes, and it was on, I think it was the one before the OGIV. Actually, no, it wasn't. Page 44, actually right above our homework. This page that we did, when we took the data and we put it in, like, we figured out how much of the data was within 1 standard deviation to, how much of the data was within 1 standard deviation from your notes. Page 44, you should have had it written down. Okay, again, doing your homework without having looking at your notes and without reading your book is kind of dumb. Okay? You're not really trying to learn. You're just trying to get something done. There's a big difference. Now remember, I didn't call any of you dumb. I said what you were doing was kind of dumb. There's a huge difference because none of you in here are dumb. You're all very intelligent. All right, so what percent of the data was within 1 standard deviation of the mean? What? 75% of the data was within. Now that's a little high, what we thought we'll find out later, but so here's the deal. When you're looking at this histogram, 75% of the data should be within 1 standard deviation. Not all of the data. So it says, is the standard deviation closer to 1 inch, 3 inches, or 5 inches? So if the standard deviation was 5 inches, what would be one standard deviation away from the mean, 15? Yeah, 10 and 20 would be one standard deviation. How much of the data is within that? All of it. Is that a reasonable thing for one standard deviation then? No, because only about 70% of the data should be within one standard deviation. Okay? So how about 3? I still have 100% of the data within, well, yeah, within 3 standard deviations above 15, within 3 units or 1 standard deviation. So what if the standard deviation was 1? 1 standard deviation, if the standard deviation is 1 standard deviation below 15 puts you at 14, and 1 standard deviation above the mean of 15 puts you at 16. Would you say that 75% of the data is within there? So what would be a reasonable standard deviation? 1. So part B would be 1. Since approximately 75% of data is there. Okay, a standard deviation, you're measuring the distance from the mean when you measure a standard deviation. Things start becoming outliers if they're more than 2 standard deviations away from the mean. All right, other questions? Yes, Emily. Which one?
22.
Okay.
Specifically
22B?
Yeah.
All right, golf drives? Okay. 22B, describe this distribution. Or maybe that wasn't 22B. 22, approximately what proportion of professional male golfers drive on average less than 280 yards? All right, so you see the histogram, right? There it is, approximately. And this one, let's see, that's 250. $280, so there's 280 right there. It says approximately what proportion of professional golfers drive on average less than 280 yards? Okay. Proportion is what? What's another word for proportion? Percent? Part of the whole? All the same. So what percent, aren't those all of the golfers of the 100% that drive less than 280? That I just circled? About what percent of all the data do you suppose that is? It's a guesstimate. Okay. A quarter. Okay. So you would say approximately 25%. This is nothing we can find out exactly right now. Were you able to estimate the mean by examining the histogram?
Yes.
Okay. Finding the balancing point, what approximately would you estimate, Jace?
285.
285? Right about there? I might go a little higher, actually. Actually, yeah, I don't know. Yeah, 285, 290, I'd say anywhere within there would be great. Because I can see a reason for 285. Yep. All right. Do you expect the mean to be smaller than, approximately equal to, or larger than the median? And why? And this is, these are the tough questions. Because is there any way for us to actually find where the median is? Yeah, actually there is. There actually is a way. How many men had neck size, how many men had golf drives approximately right here? This would assume you're looking at the histogram. Maybe one. Okay, and right here, this would be how many? Actually, hold on. How many professional golfers are on here? It tells you right in the directions. 202 golfers. So how are you going to find where the middle would be? Thank you very much, Mr. Grant. What? 202 plus 1 divided by 2. So that's 203 divided by 2, or 101.5. So you're looking wherever the 101 and a half observation would be. And that would be where the median is. So assuming, you can start and say, okay, there's 1, there's 3, there's maybe 4, 5, 6, 7, 27, 47, 47, would you say that the median's going to be right around here above 290 by the time you hit 101 golfers? Each of these stacks, how tall it is, tells you how many golfers have a golf drive in that range. So you know exactly, you can estimate where the median is. Wherever the 101.5th golfer is, that's pretty much going to be the median number. Okay? So my guess is it's probably going to be right in this 290 to 295 range. Thank you. So I would estimate that the median is somewhere between 290 and 295. That would be my estimate for the median. Okay? And we thought the mean was around what, 285, 290? That was the balancing point, but the median, you can figure these things out. Okay? So what would we say about the median? Is it bigger than, equal to, or smaller than? Well, let's see, do you expect the mean to be smaller than, approximately equal to, or larger than the median? So relate the mean to the median. Smaller than? Could you say maybe approximately equal to? Could our estimates be slightly off? Okay, they're very close to each other. So I would say slightly smaller than, or about the same as. Okay? Now look at the shape of this graph. How did you describe the shape of the graph in part A? You should have described shape, center, spread, unusual values. Shape, approximately what? Symmetric. Typically in symmetric data, the mean and the median will be about the same. Symmetric data, the mean and the median will be about the same. All right, other questions? 26. All right, so number 26 deals with cold weather. A meteorologist preparing a talk about global warming compiled a list of weekly low temperatures in degrees Fahrenheit. He observed that his southern Florida home last year, the coldest temperature for any week was 36 degrees Fahrenheit, but he had inadvertently recorded the Celsius value of 2 degrees. Assuming that he correctly listed all the other temperatures, explain how this error will affect the summary statistics.
I just need to report.
Okay. How will it affect the spread, the range, the IQR, and the standard deviation? All right, so this has to do with something I told you you'd really need to know at the beginning, and that's called resistant measures. So tell me about 2 in relation to 36. What does 2 become, really, as far as temperature in relation to Fahrenheit?
Well, are they talking about 2 degrees Celsius and 36 degrees Fahrenheit?
Yeah, but he thinks it's Fahrenheit. He recorded the degrees Celsius, and he thinks it's Fahrenheit. So describe 2 in relation to the other numbers. It's very different, right?
Yeah.
So what might it be considered? An outlier. Okay? So the question is basically, how does that outlier affect the data, the calculation? Which, should you know that? Yes, you should. because this has to do with being a resistant measure.